Today I've got some multimeter gear that I've just bought off AliExpress. They're all from the same seller. These are ANENG branded devices. I was particularly interested in this oscilloscope multimeter because I needed a new multimeter, and I thought, well, why not get one with an oscilloscope on it, because I really need to get into using oscilloscopes and things like that as I'm learning electronics. And I thought, while I'm at it, because these things were cheap, I'd grab another couple of items. And here is a pen multimeter. I'll put the models and the prices and everything in the description. This was quite cheap, and I sort of like the idea that you could hold on to it like a pen, but common sense tells me that because you don't ever see anyone using these type of things, that perhaps it's not such a good idea. The other thing is this SMT tester. So basically it's a multimeter with little probes on it, so you can get onto SMT components that are mounted onto the board. And of course I've got this little digital oscilloscope. And fortunately I have a little project that I'm about to do, which is on creating a AI device that you wear, and I'm having a little bit of problems with the power supply that I've got for it. And I thought this would be a perfect opportunity to use a oscilloscope on it, because I'm wondering whether or not the power supply is fluctuating. It's not something I can tell with a normal multimeter if there's some sort of ripple effect happening that's causing a problem, and I'll get to that in a minute. And of course this would be the perfect opportunity to also test out these other devices. Now, I'm not going to pretend that this is a review, because I don't know enough about electronics to even pretend that I can review things like this. I'm a software engineer. I do software engineering stuff all day. I'm tired of it. I find electronics really exciting. It's something that I always wanted to do. And so now I'm just gradually teaching myself electronics. And this is the next stage for me. So if you'd like to join me, this is what I'm going to do in this video. So it'll be a bit of unboxing and attempting to use them in a real life scenario as an amateur. So hopefully that will be interesting. And if you like the idea, join me, because that's what's going to happen today. So I guess we'll call this the unboxing part of it. I bought this off AliExpress from the ANENG store, and it came in this plastic packaging. It doesn't have any bubble wrap or anything. It's just plastic. So there's no protection involved in that. But I will say that it came super quick. I think in less than a week from China, from ordering it, which is almost unheard of for me. So they really did immediately post these out to me. But you can see that the packaging has suffered a little bit in transit. That's the way it came out of the bag, with the packaging crushed and stuff like that. I'm not really sure whether that's a problem or not. The oscilloscope's going to be in its own little padded pouch. So that's the way they arrived. So let's put the oscilloscope aside for the moment, and let's start with this gadget. So this is the pen type multimeter. Okay, so you can read all of the details there if you want to pause it. So it says here, item A, 3005 pen multimeter box plus 8-piece set. Okay, so let's just open it up and see what's inside, because I really don't remember what was even in the description. So lots of goodies. So there's the pen. And off the top of my head, it seems like this could be a good idea. You just you want to test various things, and the display will be right here, and you can do that. But then I guess a lot of tight spaces, you're going to be completely vertical, and so that display probably isn't going to be visible. I mean, that's probably why people don't use these, or I've never seen anyone using this type of device. So that's okay. It wasn't very expensive. So what am I getting? So we're getting a couple of leads. Let's have a look at this. Well, we're getting a lead, of course, because we don't need a lead for the end, because that's got the lead built into it, or the point built into it. So yeah, so this will be essentially the earth lead. Okay, so that comes out. You plug it into the top. And there you go. You've got your little pen multimeter. It almost seems backwards, doesn't it? Like, as I said, if you're going to look at a circuit and you didn't want to touch any of the other probes, you're more likely to have it on an angle like that, and you wouldn't be able to see the display. Whereas the earth one, you could have this onto the earth, the positive side onto the earth, and you could be using the negative side at any angle that you wanted. Anyway, I guess we'll soon find out. So what else is included with this? So we've got an alligator clip. That's really handy. So that can go on to the end of this, I'm guessing. So if you can find a big old earth connection, you can connect that to it. So yeah, so you can clip that onto a wire or onto a PCB where you can find the earth. Yeah, the alligator clip isn't horrendous. I only say that because every alligator clip I've ever got with a cheap multimeter or something like that has been terrible. This isn't fantastic, but it's not terrible. What else have we got here? Okay, so we've got this type of connector. Can that go on here? Oh, okay, yeah. So we've got different ends that can be attached to this, I'm sure. So that looks like they're screwed in. Yeah. So what have we got? We've got a flat end. Well, that's got an end with a dip in it. I don't know if you can see that. It's got a little hollow in there. We've got a really sharp, pointy one, which already looks a little bit bent. Yeah, we've got one that's a little bit longer, maybe, than the one that's in there. I don't know. Oh, here's a really long one. And we've got one here that looks like a banana jack lead on it. And we've got another fine-pitched one here, which also, the fine tip on it looks a little bit bent, straight out of the packet. All right, so that's everything that we've got. Let's have a look at the instructions. So I'll put instructions there so that you can read it if you want to pause. I'll just stick the batteries in first. It actually feels, the plastic on it and everything feels all right. I'm not saying it's fluke quality stuff, but, it doesn't feel terrible. And that's really all that there is to it. So, it's on. What's that? It's got a little flashlight on it. It's got a live voltage, so I guess that's live AC voltage detector on it. And what's this? So it looks like that might be a backlight for the LCD screen. Yeah, I like it. And then you've got just an on-off button. So very simple. We'll turn it on. 2 seconds. It's in auto. I'll turn on the back light so that you can see. Hopefully that makes it a bit better. So everything is in auto mode, and I guess the symbols come up in this little area down here. Let me, you can see the little squares there. So that will tell you what it's automatically detecting. But if you press the button once, it goes into diode mode. So you're pushing it directly into diode mode. Otherwise, it's in auto mode. So it's either auto mode or diode mode. All right, sounds good. I mean, that's simple. So why don't we actually just give it a little bit of a test? Just a smidge. So I'll take off this little booty thing. And I have this LiPo battery here that I'm going to be using for a project. And so this should be, I think it's fully charged, so it will be at a voltage greater than 3.7. And it's saying 4.14 volts. But you wouldn't, I don't know whether you can see that, but yeah, I mean, that's the disadvantage is your display is vertical. So what advantage is there for this pen? It'd be great if the things that you were trying to test are mounted on a wall and it was vertical, then, you know, pressing the two things, you'd be going like that, or your earth is down there or something like that. That would make sense. But otherwise, trying to measure things that are vertical doesn't make sense, which is probably why you don't see these things being used very often. It might be the type of tool that's great for one special job. So yeah, so there's that. So if we just touch these two together, okay. So we get the buzzing, and also it came up there, a little symbol. I don't know if you saw that, but it came up there with the ohm symbol to indicate that we were in resistance mode. Let me just check if I can find a resistor and we'll see how accurate it is. Okay, so I found some resistors. So these are 820 ohm resistors. So they're supposed to be 820 ohms and we're reading 810. So that seems about right. So in this circuit, for instance, I think I'm going to want to be testing the voltage between these two pins. That's quite good actually, isn't it? Because I'm looking down at that and, you know, if I was using it like that, still think it would be better if the multimeter was over here, but actually, you know, for things like that, maybe I'm giving it a bad rap. Let's actually try this for real. Let's turn on this circuit. This is a Raspberry Pi Zero with a LiPo battery board on top of it. So this will be a DC voltage. It's reading a bit over 4 volts. Yeah, and this is why I wanted the multimeter with the oscilloscope on it, is because I'm wondering whether this circuit is actually causing some sort of ripple effect and we're not getting a steady DC voltage. Okay, anyway, so that was just a quick play with this digital voltage pen. So I think it actually might be useful in certain circumstances. You know, just its form factor alone is pretty good when you consider how big, you know, multimeters can be. I mean, this is a small multimeter here. So that's a small one. Let me get my big one. And then you've got the little multimeter pen in the middle. So that could be quite useful. Because, you know, I say that, hey, it'd be better off having a multimeter set up. But if you consider how much space that multimeter is taking up, if you are short on space, you know, compared to using this, then the fact that the display is on a sort of an angle really might not mean anything much. Yeah, because, you know, you can just reach for this pen and use it. So yeah, I'm sure that I'm going to use this gadget. I really do think that I will reach for this device in some circumstances. As I've said, I don't know enough about electronics for me to give you a full review of this and see whether or not it's completely accurate and stuff like that. But from this, you can just see what it is and basically how it works, and check out the price down below, because from memory this was not expensive. All right, so here we have the ANENG High Precision Smart SMD Tester. So this is a tweezer-like contraption for being able to measure the different sides of surface mount components. So this one's packaged completely differently. It's actually in some plastic, and it comes with a little screwdriver, which is great, probably for the batteries. All right, there's not much to this one. So we've got our little gadget here, made of fairly solid plastic. A little bit chintzy, but you know, perfectly okay. And we've got our two little probes. Okay, this tester is handheld and battery operated, very convenient, small. Tool especially used for measuring surface mount devices, capacitors, diodes, for example. Has continuity checking. It automatically identifies passive components. Okay, so it's similar to the pen type multimeter that I was looking at. The display, so the H button holds the current reading currently on the screen. Okay, the F button switches between the different measurements. We've got our needles, needle arms down here. So the push button's F. This is the function select switch that acts as a trigger. Use the push button as a switch for between resistance, capacitance, diode, and continuity. The tester is have not power key. Okay. When installed the 3-volt lithium battery, the tester immediately power on. Once powered on, the tester will perform scanning mode, and then the scan and the something sign is displayed on the LCD. This is to indicate that the tester is in auto scanning mode and will automatically identify resistor, capacitor, diode, continuity. The F button is used for selecting some measurements mode manually. The H button to exit or enter the hold mode for any measurements. This key will act as a trigger, and the data hold mode. The tester will stop updating the LCD and store the current measured data, and then holding until pressing the H key again. Note, after auto power off is active, pushing any of these buttons can turn the tester on again. Okay. Yeah, so I really should. Sorry, So if anybody wants to read that, they can read that, and I'll do the same on this side. Hopefully, yeah, that's it. Okay, specifications: 3000 count LCD display, automatic measurement. Yeah, a lot of stuff like that. Replace the battery, open the battery case at the bottom. Doesn't say anything about how to install the arms, etc. We're just going to have to figure that out for ourselves. Is there anything else going on in here? No? Okay, and what's the model? GN701 SMD tester. Oh, okay. Okay. So it already has some pins installed on there. These pins have a groove in them. Is that for testing components like that? Maybe. Why would you have a groove in them if you're testing something like that? I'm not sure. Seems like the pointy ends would be the ones that I would be most like to use. Well, I don't know. So I'm a little bit worried about what type of battery this is going to be using. It said 3 volts. So this is CR2032. Hopefully this is the right one. So we've got the CR2032. You can hear it beep. The plastic on this feels quite cheap, but then the whole unit I think was very cheap as well. I'll put the links in the description about how much this cost. Okay, so that's it. So it doesn't have a backlight on it. And if I just press it together, what are we going to see? Yeah, it's automatically in continuity mode. So what happens if we just try this resistor? Just because I have it here handy, and obviously it's not designed for this. So this is a 320 ohm resistor with a 1% tolerance, and it's measuring, sorry, 820, and this is measuring 813. All right. Well, that sounds promising. So, okay, so I'm a bit weirded out about this, the ends on this. I'm not sure whether I can get that. You can see that it's not really sharp pointed. The tip actually has a groove in it. I'm sure there's a really good reason why they would do that. I mean, it's a bit hard to read things that are on, in circuit. So what's this here? Is this a resistor? Not getting anything from that. Oh, here we go. Yeah. So, I mean, the display is going to be upside down, obviously. If you do that, and considering I'm left-handed, the display is going to be upside down if I go to the left hand. So that could be a problem. So it's scanning, it's saying diode. Can't really see enough to even see what's going on here. So that is definitely a resistor. There's a capacitor there. I don't really know what any of these values are, so it's a little bit hit and miss. But here I am in circuit, and it's in diode mode. It's having trouble because these components are mounted onto the board, so it's probably not a fair. So that, I think, is a resistor, and it's reading it at 1 mega ohm. Okay, so basically it's not reading anything. Yeah, so let's just change the function. So this is in capacitor mode. This is in resistor mode. So you can just change it into the different modes. There's continuity mode and there's diode mode. Yeah, let's put it into resistor mode. And let's try this resistor here. Yeah, this is a bit difficult with these prongs. I'm going to swap over to these really sharp ones. Okay, so there we go. So now we've got some really sharp tips on there, which I think is more suited. So we've got this on resistance mode. So R7, 4122. So this is R7 here. 4122 is the resistance. Sorry, it'd be easier. You can see that's reading 40.9 K. Right. So there's another resistor that's reading almost 1,000. And what is that saying in circuit? That's saying 102. So is that a resistor that is, it's 10 with 2 zeros on the end of it? Is that what it means? I have to look it up. But yeah, it's definitely much easier with these type of ends on it. Yeah, so we can, and then we can just change the mode. the function, so we can change it to continuity or diode mode or capacitor mode. Here's a capacitor here. There we go. 2.5 nanofarads. Okay, so actually, I think that is easier than using a multimeter by orders of magnitude. You know, I couldn't, to get down onto those surface mount components using the normal tip, just wouldn't work, and I'd have to put this tiny little tip on it, and then, you know, you sort of got this ungainly thing, and plus you've got your multimeter there. So I think it's actually not a bad idea for this type of thing. I mean, I don't know how much use it would be to measure these things in circuit. Definitely if you had a whole bunch of tiny little surface mount components down here, yeah, it would be much, much easier to squeeze them with the tweezers and read their value. I guess we could put it onto continuity mode, and then you could be testing for shorts, you know, through the components. So, yeah. So, seems all right to me. Seems like a reasonable idea. I can see myself perhaps using that. I believe it was quite cheap. I'll put the price down in the description. It feels a little bit cheap. The plastic feels a little bit cheap. It's not backlit. You know, it doesn't even have a power off button. It's got an auto power off. You know, and these aren't 100% aligned. You know, these aren't quality leads. But in terms of actually getting to measuring through very small surface mount components, yeah, not bad. All right, it's time for the digital oscilloscope multimeter. This is the way that I received it in the package. So, not the best, but it's just a sleeve. And all the goodness is inside here. So we've got a little pouch here. It's pretty cheap. You know, cheap quality. Just feels all very plasticky. Let's see what we've got inside. All right. So yeah, so we got our oscilloscope probe in a little bag, a little zip tied bag there. So you can keep it all together. And we've got another little baggie full of oscilloscope leads, things like that. And yet another, is that a temperature sensing probe? Yes, I think it is. So we've got a temperature sensor, and we've got our multimeter leads. And here is our multimeter / oscilloscope. So we've got a little USB-C adapter, and all right, we've got a manual. Is that in English? Is it just in, is it all in Chinese? Yeah, so the manual appears to be all in Chinese, but then there's a user guide in here. Yeah, it's for the probe. So I'll just, you can take a snapshot of that if you want to read what that says. Okay, so absolutely no instructions whatsoever. So what does it feel like? It's got sort of a silicone-y feel to the outside. Yeah, the plastic isn't too bad. Like, it doesn't feel massively cheap plastic, but it doesn't feel like the best quality plastic as well. I mean, it's got a kickstand. got this little sticker here, which I have no idea what that says. And we have, wait for it, the display has a little, you ready? I don't know if you can hear this, I'll try and that's always a pleasure. Okay, so the kickstand doesn't seem to want to go back in all the way, so it's not precision engineered at all. Okay, yeah, if I give it a really good click, I can get it to sit back in place. So what do we got? We've got what looks like a normal multimeter at this stage. Obviously, we have a probe in the top, so that will be for the multimeter. For the oscilloscope. And what have we got here? In the side, we've got a flap. It says USB, so that's a USB. And then you've got the, I think this is the compensation waveform that you use to adjust the probe. You can see I don't know much about oscilloscopes. That's the whole point, though. The point about this is there are some times when I need to know more than what a multimeter can give me, and some form of oscilloscope would be great. And this is in a reasonably small package. So if you have a look at, this is a small multimeter, and this is a large multimeter. And this multimeter has an inbuilt oscilloscope. So, you know, as far as compact size-wise, I'm liking it. So if everything works, this is a good size to have sitting on my bench. So I'm guessing without the instructions, I might have to go onto the internet to see whether or not there are English instructions. There probably are. On button. What happened then? Something came up in Chinese for a moment, then disappeared. I mean, that could be anything. It could be, hey, you can't use this unless you plug in your leads, or you know, I might need to charge this thing up completely. Although, you know, these days most things come with a small amount of charge. So I might as well just go through the peripherals anyway and have a look. So these are the multimeter leads. They, yeah, I mean, they're silicon-y type leads. They're not really, really cheap leads. I wouldn't say that they're great, incredible leads either. It's got a nice sharp point tip onto these, so they're finer than, yeah, they're quite, I would say they're quite fine compared to my other multimeters. Not bad. So I'll just try that power on again. No, okay. So I think we need to charge that. Maybe perhaps I'll plug it in now while I'm checking out the rest of this. Plug this in. I'm assuming that's the way it works, that it's rechargeable, or is there a battery? I don't see any way that you can put some normal batteries in there. And what do we got now? So now we've got a red light there to indicate, I guess, that it's charging. So if I try and power that on now, ooh, okay. Nice. Look at that. We got ourselves an oscilloscope-y type arrangement. And there's a mode button. Okay, there we go. So I think that's now in multimeter mode. So let's just try this. So that's measuring voltage. So that's voltage, AC, and this is in resistance mode. This is probably auto. Okay, so 822. 822, almost spot on. And this is, so 820 ohm resistors with a 1% tolerance. So this is pretty accurate, actually, compared to my other multimeter, I think. Let me just check. I mean, this is a really cheap multimeter. 816. So I think this is more accurate. And by the way, now that I've used compared the two, this is just incredibly sharp compared to this cruddy old pin. So, okay, so it works as a multimeter. So does that mean, what about continuity? Okay, so I just press F2 again, and that changes it from auto ranging to continuity. Oh, I like that. That's really quite fast. I like that. And there's diode mode. There's capacitor mode. Cool, that works. So I've got myself a working multimeter. So that's step number one. All right. So let's just open up this next package of goodies that came with it and see what's inside this. Okay. So we've got a whole set of alligator clips to attach to this. And we've got another set of dodgier leads here. So these are not as fine as these tipped ones here. And these are the same silicon-y thing. Yeah, they're not great. I mean, I've seen worse. Not the lowest quality, not the highest quality, about what I expected. I'll put them back into there so I don't lose them within the first 5 seconds. So then we have the temperature probe, which I won't even get out. I have no use for that. They come with every multimeter I've ever had, and I've never used them. So now we come to the probe. All right, let's pull it out and see what we got. Once again, silicon-y type thing. Doesn't feel like the greatest quality. Feels more plastic than silicon. That looks to be about, I don't know, a meter. And the probe is very lightweight. So yeah, I'm not really loving the probe. It's a fairly low quality probe, as you would expect. I mean, don't get me wrong. And, you know, everything is, it's all about price too. Yeah. So that clicks into the top. A little bit difficult to do that because of this, and what's that? Is that the compensation for the probe? Yeah, it's a little bit hard to get that in because this is spinning around as well. I mean, not impossible, but you know, we got it in anyway. All right. But like I said, I mean, the whole point about getting this is that I needed a new multimeter, and if I can get some oscilloscope functionality built into it, then that's great as well. So it's time to test the functionality of the oscilloscope. Instead of going through all the functions and things like that, I'll just put a link in the description to the manual and to whatever documentation I can find if you want to look at the details. The reason for that is because I'm not really qualified to do that with an oscilloscope. The entire reason for me getting this is to learn how to use an oscilloscope. And what I've got here is an example of why I wanted to get an oscilloscope. I have this Raspberry Pi Zero device here. This is actually a video game emulator. This is called the Bare Metal Commodore 64 emulator that I made in a different video. I'll put a link in the description and hopefully a link up the top. I'm doing another project where I'm creating an AI device that you can wear. And I just happened to use the SD card with the BMC64 emulator installed on it. And when I did that, I immediately saw a problem, which I'll demonstrate for you right now. Now, the thing about the bare metal Commodore 64 emulator is that there is no Linux operating system running on the Raspberry Pi. It is a program that is talking directly to the hardware on the Zero. And this power supply, when it's plugged in, causes a problem where in the emulator, it looks like the space bar has been held down. You can see the cursor moving across, which is really weird because as far as I can tell, the only pins that are connected here are the ground and the 5-volt pins. So somehow the power supply of this board is affecting that in that way. Now that's not really a big deal. If I plug in like a normal Raspberry Pi operating system image into this, that doesn't happen because with the bare metal emulator, it's actually looking at the I/O pins of the Raspberry Pi and deciding to press keys or to simulate pressing keys on a Commodore 64. But something is causing that problem. So while I can recreate that problem, I want to attempt to fix it or to at least identify what the problem is. Now, I'm a software engineer. In software, everything is digital. It's either true or false. It's on or it's off. With electronics, it's all analog. And even when it's digital, it's really analog. So, you know, a digital signal high might be 5 volts and a digital signal low might be 0 volts. But if you have a problem with your circuit, you might be getting a fluctuating signal that's fluctuating between 1 volt and 4 volts, you know, or 1 volt and 6 volts, or 0 and 3 volts. You don't get that in software, but you do get it in electronics. And really the only way to figure that out is to use an oscilloscope so that you can actually see what's happening with the electrical signal. The problem with that is that when I've used oscilloscopes in the past, because I have no reference, I don't know what's normal. So there's always a little bit of interference that comes up on an oscilloscope screen, and I have absolutely no idea what a normal circuit looks like as opposed to a misbehaving circuit. Sometimes it's obvious, a lot of times it's not for people like me because I just don't have that experience. So this is what I really hope I'm going to get out of having a multimeter with an oscilloscope built into it, so that I can quickly switch to oscilloscope mode and do a bit of probing around circuits that are working so I can get a baseline of what normal circuits look like. So let me demonstrate what the problem is that I'm having right now with this Raspberry Pi. So I've got my LiPo battery plugged into the power board that I'm using to power this Raspberry Pi Zero. It's got the bare metal emulator, Commodore 64 emulator image on the Pi. And as soon as I turn this on, within a couple of seconds, it'll be straight into the Commodore 64 emulator. And watch what happens when I do that. You can see that I just get this cursor moving across the screen, as if the emulator is actually detecting that the spacebar has been held down. Now, as I've said, the only thing that this board should be doing is providing 5 volts. So something is triggering a problem with inside the bare metal emulator software. And as I said, it's not running Linux, it's talking directly to the Pi Zero hardware. So it could be anything. But I definitely have a problem. I've never seen this situation before. It certainly doesn't happen if I plug in a USB power into the Raspberry Pi. It's something caused by this board. So, off the top of my head, what I'm thinking is that there's something wrong with the power that's been provided to the Pi. I'm just going to stop that. So we now have a problem that I can look at, and we can start off by using the multimeter and just see what the multimeter says. Got it in multimeter mode, it's in DC. So I've already attached some wires to the pin so that I can break it out to the multimeter. So if I turn this circuit on, I've gotten rid of the display for the bare metal emulator, and let's just have a look at the voltages and see what the multimeter is going to tell us about this. All right, so the voltage, it's actually 5.3, 5.36, so it's providing more than 5 volts, and it does appear to be jumping around a little bit. Not a lot, just a little bit. So this is the point where I'm going, well, exactly what is going on? The multimeter is telling me so much, but really this is where I'm hoping that by using an oscilloscope, I'm going to get more information that's going to be useful to me. So let's switch over to multimeter mode and see what we're going to get. So I can see something jumping around. I'll just put it into auto ranging, and there we go. So I can immediately see that there is like a ripple happening on this voltage. We already know that the voltage is slightly over the 5 volts. Whether or not that should cause a problem or not, I'm not really sure. So we're on voltage over time. Can we change that value? Okay, that changes the voltage. 5 volts. Can we go down? So we go down to 2 volts. And we're down to 10 milliseconds. So we can definitely see something happening here. But this is the point where I get confused as an amateur, as somebody who's not really familiar with electronics. Is that perfectly normal? Is that a perfectly normal waveform for something like this? Because if it is, then perhaps I can narrow the problem down to something else. Fortunately for me, I have this other power board for a Raspberry Pi Zero, which is, what's it called? It's called a Pi Z Uptime board. So the simplest solution for me would be to try this and have a look, compare the two waveforms and see whether or not there's a difference, and that would give me some sort of baseline as to see whether or not that waveform is telling me that there is a real problem with this power board that will cause the Raspberry Pi to be causing that problem. So why don't we put that on and see what happens. All right, first of all, let's turn it on and see whether or not we get the cursor moving. So the cursor isn't moving with this power supply. That's the only thing that we've changed. All right. So if we now connect up the oscilloscope, we can have a look at the waveform. Right, and immediately I can see that it's a different waveform, like it's a much smoother waveform. So we can also switch it over to multimeter mode and see what the actual voltage is. I mean, I could read the voltage on there, but you know, we have an inbuilt multimeter and it's dead on 5 volts. Okay, so now I can see that there are two things which could be causing this problem. One is that the other power supply is supplying more than 5 volts. It does make me wonder whether that would cause that sort of an issue. I'm more suspect about the fact that the signal, the voltage seems a little bit dirty, and so that's something I'm going to have to investigate. I'm not going to do that now, but what I wanted to say is this is exactly what I'd hoped that I was going to get out of this device. So by having a multimeter / oscilloscope That means that I'm ready to look at circuits, even circuits or electronics that are perfectly good and are working exactly the way that they are. I can now use the oscilloscope to just poke around and get an idea for myself what things look like through an oscilloscope when everything is normal. And that way, when I need to use an oscilloscope to try and diagnose a problem, I've got that idea in my head. So that is great. I mean, I'm 100% sold on this idea. I had thought about getting one of these little portable dedicated oscilloscopes, you know, little miniature ones, having that on the bench. But if I'm going to be using a multimeter, which I have to use practically for every piece of electronics that I use, just being able to switch mode and put it into oscilloscope mode, I think is a fantastic thing. That way I can't lose the little portable device that I might have, or just go, oh, I can't be bothered doing that. It's all here. It's all here in the one unit. I think that's fantastic. I'm so happy I bought this. This is a great introduction for somebody like me into the world of oscilloscopes. Okay, that'll do for this video. If you like what I'm doing, please consider subscribing to my channel, giving me a thumbs up, leaving a comment, all of that good stuff. And I'll catch you on the next one. Ciao.